Hello everyone, I am here to explain about Poisson ratio. Everyone know the definition of the Poisson ratio, but many of them fail to use that value of Poisson ratio while solving the problems. So first of all, the definition of Poisson ratio is defined as lateral strain to linear strain or longitudinal strain. Both are same. Linear strain or longitudinal strain. First of all, what is strain? Strain is defined as change in dimension. Generally, I am talking about generally, change in dimension to original dimension. If the dimension is length, change in length by original length. If the dimension is diameter, change in diameter over to original diameter. So generally I write as change in dimension to original dimension. So lateral strain. So for this I take an example of one bar, whether it may be a circular or square or whatever it may be bar. For that bar, what I do is I'll apply some tensile load. Within elastic limit, because of this load, what will happen is the bar will try to extend. When the bar is trying to extend, where this extra portion of area coming from? This extra portion of area is coming from by reducing its width or diameter. So while conducting experiment in UTM, what you do is you can measure what is the original length and you can measure what is the change in length. So easily you will measure or you calculate what is the value of change in length and what is the value of original length. So you easily will calculate what is the value of strain. Clear? See, the strain is measured in the direction of applied load. The strain which is measured in the direction of applied load, we will call it as linear strain or longitudinal strain. But at the same time, if you observe the figure, there is reduction in width or diameter. Where we won't measure in the lab while conducting the experiment in UTM. So for that we have one constant, generally elastic constant, more specifically Poisson's ratio. This constant is constant for each material. For if you take mild steel, the value of Poisson ratio is different. If you take concrete, the value of Poisson ratio is different. So for that material, it is constant. Clear? So as per this definition, Poisson ratio is equal to lateral strain by linear strain. So for example, if it is mild steel, I know the value of mu, I know the value of Poisson ratio. At the same time, by calculating what is the value of change in length and what is the value of original length, I calculated strain. More specifically, I calculated longitudinal strain. That means I know the value of linear strain or longitudinal strain, then the value of mu. So if I know both things, I can calculate what is the value of lateral strain. What is the meaning of lateral strain? Lateral strain is nothing but strain in the direction perpendicular to applied load. See, the applied load is in this direction, but I want strain in other direction which is perpendicular. So in this direction, if you want to know what is the value of strain, then that strain is known as lateral strain. That means lateral strain is nothing but strain in perpendicular direction to applied load. So in the perpendicular direction, the strain is defined as change in dia to original diameter. So from here, I know the value of linear strain, I know the value of mu. From there you can calculate the value of lateral strain. But I also know that lateral strain is equal to change in dia by original diameter, where I can calculate what is the value of original diameter. I can measure it. So if I know what is the value of original diameter as well as what is the value of lateral strain, I can easily calculate what is the value of change in diameter. One more thing you need to look into here: when you are applying tensile load, the length is going to increase. At the same time, the diameter is going to reduce. That's why many times we define it as minus lateral strain into minus lateral strain by linear strain. Sir, is that hold good in all the cases? Yes. If you look into the same bar with compressive load, at this time the bar is going to reduce its length because of the compressive load, but at the same time the diameter is going to increase. This area will shift to the increase in diameter. So while applying the compressive load, the length is reducing but the diameter is increasing, so reverse in nature. That's why if you while solving the problems, we can define it as Poisson ratio is nothing but minus of lateral strain by linear strain. Clear? Thank you.